thing I want to talk about today is something called discrete domain and continuous domain of discrete and continuous functions. So right here, we're looking at two graphs of two different domains. Okay, the first one is discrete domain of a discrete function. A discrete domain does not connect, so they're just points on a graph. So you can write down this: discrete can be associated with disconnect. Discrete is with disconnect. So you notice that these are just points on a graph, and they're usually whole number integers, not fractions, not decimals. The next one is a continuous domain. So instead of 1, 2, 3, 4, 5, like we did in discrete, you now have a domain that goes from 1 to 5. So this is continuous here. So continuous, think of connecting. Okay, so the the domain will look like this for continuous. X is greater than or equal to 1 for this, but less than or equal to 5. So it can be any number including 1 and 5 and in between it. So it could be 1.1, 1.2, 1.3, and so forth. For this domain, this is what domain is for here, the domain for the discrete looks like this. It's a set of just 5 integers: 1, 2, 3, 4, and 5. That's it. No numbers in between them, just those 5 numbers. Okay? So here we have an example of a discrete data. Okay? This is where my domain is. So my domain is my input. It's always my input, okay? That's my domain. Whoops. So notice in my problem here, it says graph the function using a domain of 0, 1, 2, 3, 4. So here's my domain, 0, 1, 2, 3, and 4. I know that gives me a clue. If it gives me this clue, I know that I'm going to have a discrete domain. It's actually going to tell me what my numbers are. In this problem, if you read it thoroughly, it says a function y equals to 15.95x, which represents the cost in dollars of X tickets to the South Florida Museum. So think to myself, if I'm going to buy tickets to a museum or tickets to a movie, can I buy half a ticket? No, I cannot. I can only buy one whole ticket, right? Or if I want two, I got to buy 2 whole tickets. I can't buy 1.5 tickets. So the main clue is you cannot buy part of a ticket in this problem. That's why it's discrete. And the second part is they tell you what your domain is specifically: 0, 1, 2, 3, and 4. That's why this domain is discrete. You notice in the graph, it is a bunch of points on the graph. They are not connecting. Okay, in this function, you actually have a continuous domain because it does not tell me a specific whole number of bars. It just tells me a number of bars that can be eaten. So we can think to ourselves, we can actually eat part of a bar and save the other part for later. So since we can do that, then the domain is continuous. If you look at the graph to the left, I connect all my points with a line through them. So my domain can be whole numbers, but they can also be decimals or fractions. Again, my domain is my input. So I can have a half of a bar, I can have 1.5 bars, I can have 2.5 bars, and so forth. Okay. On example 3, you conduct an experiment on the speed of sound in dry air at 86 degrees Fahrenheit. You record your data in a table. Which of the following is true? So remember, my input is my domain. So I look at my domain here. And I notice that I'm dealing with time in seconds. So if I'm dealing with my input time in seconds, then notice that my domain has to involve t in the answer. Which two answers can I immediately cancel since it doesn't have t in the answers? So if I look at my answers carefully, I notice that I cannot have d as part of my domain, which is here in this situation, the output says d in miles. But my domain says it's t in seconds. So since all of my answer selections deal with domain, I have to cross out the wrong answer choices, which is C and D, since they deal with D as my output, which is incorrect. So now that leaves me A and B as my two possible choices. Which one do you think is correct? So the answer is B. It can be continuous because time intervals connect with each other. So if they say connect, remember connect means continuous. Okay? Connect means continuous. All right? Very good. Very good. So I can have 1.1 seconds, 1.2 seconds, 1.25. If you ever watched the Olympics, like the 100 meter dash, 200 meter dash, you see that they always read the time, not just 20 seconds or 10 seconds, they say 10.101, okay, or 10.2 or 9.79. Okay, it's not just whole numbers, they have decimals after it too, or you can have fractions. So in this function, since we're dealing with number of minutes, and they don't tell you 1, 2, 3, 4, 5 is my domain, they give you a plethora of time, as in it can measure any moment of time. This is going to be a continuous domain. And you can check using a stopwatch. Okay, so again, the domain of this function is discrete because we're dealing with whole numbers. Okay.